Okay, so I have two recordings then. So now we're addressing this question here, 45 to 48, and it has to do with z-scores. Now I haven't really discussed z-scores with you guys, but let me give you the formula for it. Z-score equals x minus x bar divided by s. And what this effectively does is it tells you how many standard deviations a particular score is from the mean. So in this case, we have a bell shape, right? And this bell shape is composed of 19 numbers, 19 students, high school football players in this case. And it says that the mean x bar is 186 with a s of 18. Now, when we did empirical rule, I'm going to go ahead and just go 1 standard deviation, 2 standard deviations, 3 standard deviations, 1, 2, and 3. So this is positive 1s, positive 2s, positive 3s. That 1 standard deviation, 2 standard deviations, 3 standard deviations, negative 1s, negative 2s, negative 3s. So if you take 186 and add 18, you get 204. And then if you add another 18 to it, you get 222. And you take another 18, 240. And you do it in the opposite direction again. 186 minus 18, that's 168. Minus 18 again, that's 150. And then 18 again, 132. So now let's take a look at 213. 213 will be like around here. So if you take 213 and you apply z-score to it, you say, okay, this is your x, 213 minus 186, which is your mean, and divided by 18, you'll get a decimal. 213 minus 186 is 27. And 27 divided by 18 is 1.5. So I guess that will be like somewhere around here. Sorry. That's 1.5 standard deviations away from the mean. See, it's not at 1s. It's not at 1s. It's not at 2s. It's at 1.5s. It's 1.5 standard deviations away from the mean. So there's where this would be. This would be effectively, this is 1.5s. We don't write it that way. We just realize it's 1.5 standard deviations from the mean. By the way, we consider that, we don't consider that number unusual. We consider numbers unusual if they have 2 standard deviations or more, or negative 2 standard deviations or less from the mean. If we recall, by the time we got to 2 standard deviations, we have 95% of the data contained within there. All right. So let's go ahead and do number 46. Number 46 says we're going to do a z-score, 141 minus 186 divided by 18. So 141 minus 186 divided by, oops, I was going to make that mistake right now. Of course I made the mistake because I'm supposed to find my numerator first. 141 minus 186, find that number and divide it by 18. That's negative 2.5. So that guy, that 141 is going to be somewhere around here. And so that's negative 2.5s. That's 141. That is unusual. Anything beyond 2 standard deviations or negative 2 standard deviations would be considered unusual. So this is unusual. It's I've misspelled unusual, of course. Unusual. It's too far away from the mean, from the center. This is our mean. It's getting far out there. In general, if it's 5% or less, we consider it unusual. In this case, 2 standard deviations makes 95% of data. Anything beyond that will be taken up by the remaining 5%. And therefore, those are too far away. We start considering kind of unusual. All right, let's do the next one. Z-score is, remember, it's x minus x bar divided by s. That's 178 minus 186. That's really close to the center, divided by 18. So that's like really close. That's like somewhere over here. That 178 is somewhere there. So we're going to 178 minus 186 divided by 18. That's negative 0.44. Now, something to mention here. Right here in the middle, we have a z-score of 0. The mean is a z-score of 0. To the right of the mean will be positive z-scores. To the left of the mean will be negative z-scores. And the final one, which we know it's going to be somewhere over here, you could already tell it's unusual. X minus x bar divided by s is 249 minus 186 divided by 18. Of course, it's a positive z-score. But 249 minus 186 and divide that by 18, we have a 3.5, 3.5s all the way out here. That's what the z-score means. The z-score stands for how many standard deviations a particular score is from its respective mean. It takes into consideration the mean and the standard deviation. And of course, this is definitely unusual. So remember, if the z-score is greater than or equal to 2, or z-score is less than or equal to -2, then it is considered unusual. Fair enough? Hey, I'm pretending to be a teacher. So I'm going to stop